Hello everyone. Today I'll show the solutions to problems 5 and 6 of round 167 of the Prairie Math League. For problem number 5, we have a triangle ABC, and medians AD and CE intersect at P. So what the medians say, what the medians mean is basically we have a median AD in the triangle ABC. In this case, these two sides will be equal. So the definition of a median is that when there's a median, it hits the opposite side and bisects it. In other words, divides it into two equal lengths. And we're also given that this intersection is P. PE is equal to 1.5, PD is equal to 2, and a DE is equal to 2.5. That's hard to see. 2.5, but they're better. What is the area of AEDC? In other words, the green region. So now, we can take advantage of a useful lemma in geometry that says that the medians intersect each other with a 1:2 ratio. So in other words, what I mean is that this length here is equal to twice this length, or this is equal to 3, and similarly this length is equal to twice this length, or 4. And this also implies that this is twice this length, so this would also be 5. Now, the proof is not so hard. So to prove this, we first note that we use side angle side similarity. This divided by this is equal to this divided by this, and this angle is shared, obviously. So triangle BCA is similar to triangle BDE. Now, this means that this angle is equal to this angle, and this angle is equal to this angle. Therefore, these two sides are parallel. This implies that this angle is equal to this angle, and this angle is equal to this angle, which implies that these two triangles, DEP and ACP, are similar. But what is more, since these two triangles are similar with a 1:2 ratio, this triangle must also be similar to this triangle with a 1:2 ratio, because this is 2.5, and therefore this must be 5. Now, this implies that this is equal to 3, this is equal to 4, and this is equal to 5, as desired. Now, you might have noticed this when we were first given the side lengths, but now it's completely obvious that this is a 3, this is a 4, and this is a 5. Therefore, we are looking at a 3, 4, 5 triangle, which is a right triangle. Now, since these are similar, we can see that this is also a right triangle. So this motivates us to get the altitude to this right triangle, because if we're looking for the area of this green shaded region, we have the bases now. We just need to find the height, and we can just find the heights of these two right triangles. So notice, okay, you can't see the point labels anymore. I'm just going to draw them again. So notice that, okay, let's call this x and this y, where this is you drop p to AC and DE respectively to get y and x. Now notice that py times AC divided by 2 is twice the area. Oh, sorry, py times AC is twice the area of APC. But since APC is a right triangle, this is also equal to AP times PC. Therefore, py times AC is equal to PA times PC. And since we know everything else but py, we can use this to solve py to be 2.4. And with a very similar argument in the other triangle, we can solve px to be 1.2. And we can add these up, because this is one straight line, to get 3.6. Finally, we have the height. We have the two bases of the trapezoid. And we can calculate the area using the trapezoid area formula to be 13.5, which is option choice B. Now, for problem number 6, we're given this somewhat scary-looking expression for P, and we have to find e to the power of P, or to be more specific, we have to find the largest power of 2 that divides e to the power of P. To do this problem, we're going to rely on 3 very important exponent rules. First of all, if we have a sum in the exponent, this basically translates to a product in outside the exponent. So e to the a plus b equals e to the a times e to the b. In this case, this choice of base is arbitrary. We could have chosen something like 3 or 2 instead. But since e shows up in this problem, we're going to stick to e for now. or the second one is that to the power of AB is equal to e to the power of A to the power of B. Again, this is somewhat standard, so like all these rules you can find in like any sort of textbook on exponents, so I would recommend looking into this if you got stuck on this problem. But anyways, and finally, e to the power of ln a is equal to a. This is a generalization of the lemma that n to the power of log base n of any number is equal to this number. So we have these three rules in mind, and we're now ready to solve the problem. So this might look scary at first, but we can just kind of write it out like this. 1 times natural log of 1 plus 2 times natural log of 2 plus 3 times natural log of 3 until 6 times natural log of 6. Then we can directly apply rule 1 to get that a bunch of like products. E to the power of 1 times natural log of 1 times e to the power of 2 times natural log of 2, etc. Now we apply rule number 2, but instead of taking 1 into here, we're going to take ln of 1, because this allows us to get e to the power of ln 1 inside the brackets, and we can instantly simplify this by rule number 3 to get 1 for the first one and 2 for the next one, and so on. So this scary looking expression, e to the power of summation k ln k, is literally equal to 1 to the 1 times 2 to the 2, etc. times 6 to the 6. And while this is still somewhat of a big number, it is definitely easier to work with, because we don't have any exponents, like any annoying e's anymore. So we now move on to the next phase of the problem, which is actually extracting the answer. So notice that 1 is odd, 3 is odd, and 5 is odd. So we can ignore that because we are looking for powers of 2. Now 2 to the 2 times 4 to the 4 times 6 to the 6 is we're basically looking for all the powers of 2 in here. Now notice that 2 is 2 to the 1, 4 is equal to 2 to the 2, and 6 is equal to 2 times 3, but since 3 is odd, we can just drop it. So the number of powers of 2, the maximum power of 2 that divides this is therefore 2 squared times 2 squared to the 4 times 2 to the power of 6, which is 2 to the power of 2 plus 8 plus 6, which is 2 to the power of 16. And that is option choice C. And we're done. Thank you for watching.